Inshallah, in today's class, we are going to continue Maxima Minima by Lagrange's method of undetermined multipliers. Lagrange's method. So we have to find Maxima Minimum by using Lagrange's method. This method is uh, useful when we have to find maximum or minimum of a function, but some conditions will be given subject to the condition. So to find the maximum or minimum of a function when some conditions are given, then we can use Lagrange's method, finding some maximum minimum of a function which is subjected to some condition. Suppose condition is g and we have to find the maximum or minimum of f. So what is the steps you see here? I'm explaining the method. First we have to keep, suppose capital F equals to small f plus lambda into g. Lambda is the undetermined multiplier. What is f? Small f is the function whose maximum or minimum we have to determine, and g is the subject condition, given condition. So then we have to suppose g equals to equation 1. We have to find dou f by dou x, dou f by dou y, dou f by dou z, and equate to 0. Dou f by dou x equals to 0, dou f by dou y equals to 0, dou f by dou z equals to 0. Let me denote this by equation 1, equation 2, equation 3, and equation 4. Using this 4, we have to solve and find the values of x, y, z. Solving 1, 2, 3, and 4, we have to find the values of x, y, z. These are the stationary points. So lastly, to get the maximum or minimum, we have to substitute the stationary points in the given function. We have to substitute the stationary points in the given functions, in the given function. So let me do one example using these conditions. Now see here, find the minimum value of given that. We have to find the minimum value of this function, and the given condition is this, given that x, y, z equals to aq. Let me start like this. Take the function as a small f, whose we have to find the minimum value, x square plus y square plus z square. Suppose this by, you see here, I'm writing x, y, z equals to aq. Note this as 1. Now bring this here and suppose by g, let g equals to x, y, z minus aq. We suppose the function whose maximum or minimum we have to determine by small f and condition by g. Now the first step is, just now we discussed, we suppose this by capital F equals to small f plus lambda into g. Capital F equals to small f is x square plus y square plus z square plus lambda into g is x, y, z minus eq. Now we have to partially differentiate with respect to x, with respect to y, with respect to z. Now dou f by dou x equals to d by dx of x square is 2x. We don't have x here 0, we don't have x here 0, x is 1, 1 into lambda z, y lambda z. We don't have x here 0. Similarly, dou f by dou y, dou f by dou y. Y square is 2y, y is 1, 1 into xz, xz, lambda xz. Similarly, dou f by dou z equals to 2z plus lambda xy. So next step is we have to equate this to 0. We have to equate this to 0 like this. Dou f by dou x equals to 0 implies 2x plus lambda yz equals to 0. Here dou f by dou y equals to 0 implies 2y plus lambda xz equals to 0. Dou f by dou z equals to 0 implies 2z plus lambda xy equals to 0. Now let me note this one 2, this one 3, this one 4. Now we have to solve this, solving using 1 also, 1 comma 2 comma 3 and 4. Now how to solve, you see here, there are many methods. I am doing one method. From this I am finding lambda, from this lambda, and from this lambda. So bring this here, lambda yz equals to minus 2x, bring yz, lambda yz equals to minus 2x. Therefore, lambda equals to minus 2x by yz. Here also what can say, lambda equals to minus 2y by xz. Here also lambda equals to minus 2z by xy. Now see here, this 3, both, all these 3 are the values of lambda. Therefore, these 3 are equal. Therefore, minus 2x by yz equals to minus 2y by xz equals to minus 2z by xy. Minus 2 minus 2 minus 2 will get cancelled. First equate this 2, you will get one value, x by yz equals to y by xz, and equate this to y by xz equals to z by xy. Now from this 2 you see here, this z will cancel, you get x square equals to y square. Now here also you see here, this x cancel, y square equals to z square, y square equals to z square. That means these three are equal. Therefore, x square equals to y square equals to z square. X square equals to y square equals to z square. Now let me do one thing. Or we can say like this, take out the squares, x equals to y equals to z. X equals to y equals to z. Now, let me substitute this in 1. Substituting in 1. What is 1 we are having? X, y, z equals to aq. Now, x, y, z are 3 are equal. So, x into, in place of y we can write x, into, in place of z we can write x equals to a cube. That is x cube equals to a cube. Cube will get cancelled. So, x equals to a. These three are equal now. Therefore, y equals to a, z equals to a. Therefore, we got the point. Therefore, stationary point is x is a, y is a, z is a. Now we have to find the minimum value. We have to substitute the given question. Therefore, minimum value. What minimum value? We have to find the minimum value of x square plus y square plus z square. So x is a, y is a, z is a. So substitute this one, a square plus a square plus a square. So this will be 3a square. This will be 3a square. Now see here, next question. Find the maximum value of, already the given function is denoted by u. So let me take u only. X square y cube z power 4. This you note as 1. 2x plus 3y plus 4z equals to a. This is the given condition. Bring this a here. Let me denote by g. Let g equals to 2x plus 3y plus 4z minus a. Now let me denote this by capital F equals to u plus lambda into g. Capital F equals to u is x square y cube plus, sorry, into z power 4 plus lambda into g is 2x plus 3y plus 4z minus a. Now let me differentiate with respect to x. Dou f by dou x. With respect to x means x square is 2x. So this will be 2x y cube z power 4. With respect to x means these are constant. Z is constant, y is constant. X is 1. 1 into 2 lambda, 2 lambda. Similarly, dou f by dou y. With respect to y means y cube will be 3y square. So write 3 in the beginning, y square z power 4. With respect to y means this is constant, this is constant. Y d by dy of y is 1. 1 into 3y, 3 lambda, 3 lambda. In the same way, let we differentiate with respect to z. Dou f by dou z equals to z power x power 4 is 4x cube. So this will be 4z cube. 4x square y cube z power cube plus, this is 0, this is 0, 4 lambda, 4 lambda. This is the first step. Now second step, we had to equate this to 0 and find the stationary value. So dou f by dou x equals to 0, dou f by dou y equals to 0, and dou f by dou z equals to 0. Now let me solve this one. Dou f by dou x equals to 0 means this will be 0. So let me do one thing. 2xy cube z power 4 plus 2 lambda equals to 0. Let me do one thing. Bring this lambda here. 2 take the common 2. Or else bring this here. So lambda equals to minus zy cube z power 4. Now here also if you take 3 common, 3 will go. What is left here? X square y square z power 4 plus lambda equals to 0. Or we can say lambda equals to minus x square y square z power 4. Now from here you will get lambda equals to minus x square y cube z power 3. Now see here, let me do one thing. Let me denote this by Suppose this is 2, this is 3, this is 4. Now this lambda values means this 3 will be equal, lambda equals to lambda equals to lambda, same. Therefore we can say minus x y cube z power 4 equals to minus x square y square z power 4 equals to minus x square y cube z cube. Let me equate this to, then this to. Let me equate this to again, minus x y cube z power 4 equals minus x square y square z power 4. Let me cancel this, z power 4, z power 4 cancel, minus minus cancel, x square cancel, y square y cancel. What we got here, y equals to x. Similarly, let me equate this to minus x square y square z power 4 equals to minus x square y cube z cube. Minus minus x square cancel, y square y cube cancel, z cube z cancel. So y equals to z. Now equate this 3. Therefore x equals to y equals to z, x equals to y, y equals to z. Therefore x equals to y equals to z. Let me substitute this in 1. What is 1 here? We are having 1 as 2x plus 3y plus 4z equals to a. Now watch carefully. 2x plus 3 into y we can write x, plus 4 into z we can write x equals to a. 4, 5, 6, 7, 8, 9. 9x equals to a. Therefore x equals to a by 9. X, therefore x equals to a by 9 means all these are 3 equal. Y equals to a by 9, z equals to a by 9. Now let me substitute this in the function to get the maximum value. Therefore maximum value, no, maximum value, where we have to substitute in the function, given function, x square y cube z power 4. So this will become, now let me substitute the value. X means a by 9 square, no, apply square, a cube, y a by 9 cube, a power 4 by 9 power 4. So this will become a by 9. Bases are no same, we add the powers, 4, 5, 6, 7, 8, 9. A by 9 power 9. Now you see the next question. A rectangular box open at top is to have volume 32 cubic feet. Find the dimensions. Dimensions means length, breadth, height of the rectangular box. We have to find the length, breadth, height of the rectangular box, requiring least and a minimum material for its construction. So we want lateral surface area. You see here. Suppose let me having one open box. Now see here. Suppose this is the box. Now see here, open at the top means actually, suppose let me make this length b equals to x, breadth b equals to y, and z be the height. Z be the height. Now see here, we are having actually 5 faces because this face is open. So we doesn't require material here. So we require the material here, 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 okay, and the top and the back. That means actually we want six faces. We are having 5 faces to be required for the 1, 2, 3, 4, 5. This is top is not here. So what should be this? Let start like this. Let length equals to x, breadth equals to y, and height equals to z. Okay. So what will be the area? Actually, we have to find the least surface area because by this surface we require material. We require the material for the surfaces of the box. So therefore, we have to use the area of formula of surface. How we have to use? You see here, we are having this side only one. So length into breadth, one rectangle, rectangle, length into breadth. But we are having this two, this two. So we write 2 into yz plus 2 into zx. Got it? Watch here. We are having 2 rectangles. This 2 into yz, 2 this 2 into zx. But we are having only this one. So this is only 1x, right? Whereas 2 in 2. We are multiplying with 2. We are having 2 faces, 2 rectangles. This, those 2 rectangles, this, and this is 1 rectangle. So I wrote like this. Okay. So I'm writing like this. A. And what is given here? What is the condition here? So this is the surface area formula. Next thing is what is given here, volume should be 32. That is volume is x y z equals to 32. Now let you note this as 1. Now how to write, let I'm writing like this, capital F equals to a plus lambda into this volume. Let me denote by g, x y z minus 32. Okay, or we denote by v only. Know this is v, so this is v minus 32. Okay, plus lambda into v. So f equals to a is xy plus 2yz plus 2zx plus lambda into what is the volume, xyz minus 32. I am denoting this by xyz minus 32 by g. So I am writing g here. Okay. Now what we have to do, differentiate with respect to x, with respect to y, with respect to z. So dou f by dou x with respect to x, d by dx of x is 1. 1 into y is y. We don't have x here. X is 1. 1 into 2z is 2z plus 2z plus x is 1. 1 into yz, yz. Lambda into yz. Now dou f by dou y with respect to y is 1. 1 into x is x. Y is 1. 1 into 2z is 2z plus y is 1 lambda x is z. And lastly what we have to find, dou f by dou, okay, dou f by dou z with respect to z. We don't have z here, 0. Z is 1. 1 into 2y plus 2x plus lambda xy. So what is the next step? We have to equate this to 0. Dou f by dou x equals to 0 implies y plus 2z plus lambda yz equals to 0. Let me find lambda from this. Bring this 2 on the other side. Lambda equals to minus y minus 2z divided by yz. Now let me find lambda from this. Dou f by dou y equals to 0. That is x plus 2z plus lambda xz equals to 0. So what will be the lambda? Bring this to here. Minus x minus 2z divided by xz. In the same way, let me find here dou f by dou z equals to 0. So this is here 2y plus 2x plus lambda xy equals to 0. So lambda equals to minus 2x minus 2y plus xy. So let me denote this by equation 2 by 3 by 4. Now let me have to solve this. Solving this same as the previous method. Let me equate this to, then this to. So first let me equate this. I am taking minus common, y plus 2z by yz equals to minus, if you take common, x plus 2z by xz. Now see here, minus minus will get cancelled. In the denominator, y will get cancelled. Now you cross multiply this, x into y, xy plus 2xz, x into z, xz plus, see here we done some mistake. This is xz, not xy. This is xz. This is yz. So what will get cancelled? Z cancel. Now you cross multiply x into y, get xy plus 2xz. Now multiply this x into y, xy plus, if you multiply this to 2yz. Once more you see here, x into y, xy, x into z, xz, 2xz, y into x, xy, y into z. Now you see here, you get cancel this one, xy get cancelled, 2 will get cancelled, z will get cancelled. What is left? Y equals to x. Y equals to x. Now let me equate this to, once more you see here, we cross multiply xy plus 2xz equals to xy plus 2. So we get cancelled, we get y equals to x. Now in the same way, let me equate this to minus x minus 2z by xz equals to, let me take minus common, minus 2x plus 2y by xy. Now you cancel this one, x will get cancelled, minus minus get cancelled, cross multiply x into y, xy plus 2yz equals to 2xz plus 2yz. Now 2yz will get cancelled. What is left here? X will get cancelled. X will get cancelled. Y equals to 2z. Here y equals to x, y equals to 2z. Let me substitute in the equation 1. You see here, I am continuing here. Now what is equation 1? Equation 1 is volume. What the volume we are having? You see here, I am continuing here. X, y, z equals to 32. We got y equals to x and y equals to 2z. Now let me substitute this in the equation. In place of let me write like this. In place of x you write y. So in place of x if you write y into y. In place of z we can write y by 2 equals to z. So z is y by 2 equals to 32. Y into y into y cube. Bring this 2 here, 64. So y cube equals to 4 cube. 64 is 4 cube. Cube cancel. Therefore y equals to 4. X equals to y. Therefore x equals to 4. Now z equals to y by 2. So z equals to 4 by 2. Z equals to 2. Z equals to. Therefore we can write like this. Length equals to 4. Breadth equals to 4. Height equals to 2. Feet, no feet. Now let me do one more last question. See here. Find a point on the plane which is nearest from the origin. I'll explain like later. Suppose this is the plane. So suppose yeah, here is the origin 0, comma 0, comma 0. Now we have to find a point on the plane which is nearest from origin. Suppose the point be x, y, z. Now the distance from the point, this distance should be nearest means minimum distance. So distance from origin is formula is x square plus y square plus z square under root of. This is the distance. This is nearest distance means minimum distance we have to find. Nearest distance means from origin to the point nearest we have to find the distance formula, nearest distance. Okay, least minimum distance. So let me start like let p x comma y comma z be the point. Be the now what will be origin 0 comma 0 comma 0. Now what is the distance? This distance we have to find the minimum distance is under root of x square plus y square plus z square. Let's see here. If we take like this, then we have to differentiate will become somewhat difficult because root is there. So without root also we can solve. Will you have the same maximum minimum with root or without root, because the values will be same. So let I take like this. If you square this, what will happen? OP square equals to x square plus y square plus z square. Let me denote by this small f, x square plus y square plus z square. Now what is the plane given? This is the condition. Plane given is 3x plus 2y plus z minus 12 equals to 0. Note this as 1. And let me denote with this by g, 3x plus 2y plus z minus 12. Now what is the method we are having? Let capital F equals to, let capital F equals to small f plus lambda g. Capital F equals to small f is x square plus y square plus z square plus lambda into g is 3x plus 2y plus z minus 12. Now let me start doing differentiating this one. Dou f by dou x with respect to x. Dou f by dou x. D by dx of x square is 0, 2. Sorry, this is 0, this is 0. X is 1, 1 3 is 3 plus 3 lambda. Now dou f by dou y equals to 2y plus 2 lambda. 2y plus 2 lambda. Now dou f by dou z equals to 2z plus lambda. D by dz of z is 1, 1 into lambda, lambda. Now next step what we are having, we are equate to 0. Dou f by dou x equals to 0 means 2x plus 3y equals to 0. So lambda will be minus 2x by 3. Bring this 2x here, minus 2x. Bring this here. So dou f by dou y equals to 0. What will be here? 2y plus 2 lambda equals to 0. We can take 2 common, so lambda will be equals to minus y. Lambda equals to minus y. Now lastly, from here, what we are having? 2z plus lambda equals to 0. So lambda equals to minus 2z. Now let me equate this 2, then this 2. Therefore, minus 2x by 3 equals to minus y. Minus y will get cancelled. So I am doing one thing. Let me change this in terms of y. Bring this to here, x equals to 3y by 2. X equals to 3y by 2. Now compare this to minus y equals to minus 2z, minus minus cancel. Z equals to y by 2. Now we got x and z in terms of y. Let me substitute in the given. What is equation 1? Equation 1 is 3x plus 2y plus z equals to 12. 3 into x. The value of x is 3y by, sorry, 3 into x is 3y by 2 plus 2y plus z. Z is y by 2 equals to 12. Now what you get the LCM? 2. 3 3s are 9y plus 2 2s are 4y plus y equals to 12. This will be 24. 9 plus 4, 13 plus 1, 14. Let me do one thing. 9 plus 4, 13 plus 1, 14y. 14y equals to 12. Therefore, y equals to 12 by 14 means 6 by 7. So we got y equals to 6 by 7. 6 by 7. Now you substitute here. Sorry, 2 12s are 24. No, this is 24. So this will be 12 by 7. 12 by 7. Now substitute this here. X equals to 3 by 2 into y. Y is 12 by 7. 2 1s are 2 6s. So x equals to 18. Sorry, 3 6s are 18. 18 by 7. So lastly, what is z here? Y by 2. Z equals to y by 2. So z equals to y is 12 by 7. By 2 means 2 here. 2 ones are 2 6. Therefore, nearest point will be x is 18 by 7. Y is 12 by 7 and z is 6 by 7. This is the nearest point. If we ask the distance, then what is the distance formula? Under root of x square plus y. It is not asked here. If we ask what is the minimum distance, we have to use the distance formula, x square plus y square plus z square. If it is asked what is the minimum distance, means then we have to find the distance under root of x square plus y square plus z square. But here only the point is asked. Here is the question finished. Okay. So inshallah, in the next class, these few questions we have done based on the Lagrange's method. You practice by yourself 1 or 2 questions more to get the perfection. In the next class, inshallah, we will be seeing the Taylor's expansion of 2 variables. Inshallah, we will continue in the next class. Always request to like, share and subscribe my channel. Inshallah, we are going to continue in the next class.